Hello and welcome to Lands Unknown. My name is Will, and today we are going to continue mapping the Tyche Basin, doing the climate mapping, physical geography. Last time, we were going through a lot of these S climates, the A and CS, and marking in for elevation after we figured out where the CSA and A ones were. Oh, Ukarej is already here. Hello, Ukarej. Good morning to everyone. It's morning for me. And of course, the sun is out. Here we worship the sun. All right, let's change that. There we go. Hello, Explorer Kate. You posted it like 3 hours ago. Oh. Hello, anyway. No, it's hello again. Yes, the sun sign. Oh. All right, so where we left off. Hello, Jan. Yan? Yan Alolan? That does rhyme. That may be good. So, where we left off last time, we had okay, this will work. Wet brush paper. That is not a good brush for this. I'm probably using it for something else. So from last time, what we were doing was in this area here broadly, just kind of going through and checking the temperature at elevation to see what changes were. I think we finished this terrain here, that kind of failed microcontinent. Now we are going to go in and check this one. We're just going to crack right in. That's what everyone's here for. Climate. Okay, so if we are looking, so just got to remember where all my stuff is. It's been a busy week. We started doing labs and stuff. Started teaching, it's the second week of teaching students, starting to submit things, starting to like mark and return things and stuff like that. So getting a bit more busy. Hello, Writer2 and Catherine Rayner. Or Catherine Ayer. And hopefully this time we don't have the background noise of my laptop whirring because I've removed my laptop from the setup. Okay, there we go. That works. The mic has been reconnected. There have been 0 days without any disturbance. What is it? Tech failure? Yep. All right, so we're going to go into here and check our July temperature. Yeah, so, oh yeah, I think I did that around last time. Oh yeah, so 19 and 13, brilliant. Yeah, 13, 14. So this would actually become would it transition to CSC? Now that one's interesting. So if we, yeah. Because at about 500, this would be 10. And, oh, yeah. Never mind. All right, so at 500, that would be 16 and 10. At 1,000, we would get to about, 12 and a half, 13, and 7. So that would be ripe for our CSC climates. Assuming everyone can hear me again. After I said the mic's disconnected, no one's posted a comment. Okay. Can hear. Mic is good. Excellent. Thank you so much. So we actually have a decent amount of that, 1,000 we're looking for in here. But we're not going to get any ET. These mountains just aren't that tall. I accidentally switched to the eraser. Wonderful. That doesn't happen at least once a stream. Okay, so we're going to make this a smaller brush. So I can't have... There we go. This is just off-the-cuff world building. Just sitting down in the morning, hoping the mic works. You're a little quiet on my system, but I turned up the volume, so all good. Yeah, so let me try to increase it on my side. I did decrease it from last time, so. Test 1, 2. Let's see if that's better. I'll make a note if that's better. Yeah, so now it's turned up. It should be, yeah, that should be good. I'm also a quiet person, and I'm just sitting alone in a room talking to myself. I don't have that, like, I don't know, inside streamer voice. Oh, it sounds better. Okay, excellent. Like usually when I'm talking about this stuff, there's a classroom or like, people on Zoom or something like that. This is just me looking at a screen, vamping, I suppose. Yeah. I mean, one of the things here is that these lines are a little irregular, but that's okay because after I finish this step, I'm going to do that satellite version and then refine the climates from that satellite version. But I don't think anything else on this terrain. Oh, yeah. We have to check here too. We have to check this region. Yeah, so we do want to... Oh, what's going on? Oh, yeah, that's an invisible layer. Thank you, invisible layer. Do want to check in here. That is near... Oh, yeah, I said that's near the 20, so we can say that's about 20 or 20 and a half. We'll see if that makes much of a difference. About 20 or 20 and a half in the summer. And yeah, about 14 or so in the winter. I mean, this is a pretty big basin. And in the winter, the wind's moving this way, so the warm would come down. The warm water would be pushed this way over the surface. And yeah, so it'd probably be coming down that way, because we have the circulation going this way at the surface. The subsurface ones stay the same. That circulation is going to be staying the same. So yeah, we'll say 14. It'll probably be a little chillier. It's okay. And at 1,000 here, it would probably be 13.5. Yeah. It probably peters off. So the main difference, let me check. So I may want to... So we probably have some up in here, but that'd be it, because that's where we would probably see the height of it. Oh, because this is 1 to 2,000, right? Yeah, the yellow's 1 to 2,000, so... Well, we can... Well, I would say here would probably be the maximal extent of it. Yeah, okay. Because the steps that we have are 0 to 250. Oh yeah, you can't see what I'm doing because I'm not marking anything. So from here to here is 0 to 250. Here to here is to 500. This is to 1,000, the light green, and then this is 1,000 to, what is it? 2,000. Yeah, it's 1,000 to 2,000. So we would see it in this region up here. However, over here, we would probably see the entirety of that yellow spot. So I can make my life a little easier here. Oh, yep, picking the wrong layer. Oh, there we go. Cool. Oh, that's funny because it's also grabbing the thing there. Neat. Yeah, it's suitable. Now this is where I'm going to turn it up so I can make sure I get everything in there. Okay, and then I will go back to the CSC and grab those areas. And then hopefully when I turn that off, hey, that looks good. Cool. Oh, I didn't grab that upper area. That's all right. You can probably hear all the little pink, pink, pinks from the pen tapping around. There we go. What is it not grabbing? Okay. Yeah, it's pretty all right. And it does just kind of stop there and then continue. Okay. So now looking at here, when I did that, since it only starts... So I may, for this, have it start here. We'll have it kind of weave through. It is certainly going to appear around here, and it would start at, because that's 1,000. Lovely. That's 1,000, so let's just do 1K. It would firmly start, 1.1 up there. However, down here, it starts at 1.5K. So we are going to, start a little closer to the border between the yellow and the green. And then when we go over here, we are going to give a bit more distance. Yeah, because by the time it reaches here, it should be about halfway. There we go. Great. And of course, it's very confusing when I choose the same color for that as I do for this. There we go. Yeah, that's great. So then for this region, because we do have some pretty, extensive mountains here, we can figure out when it would become ET. And I'm going to do that for this region up here as well. That is CSC, yes. Just make sure this is dark. Great. Writer 2, when did you ask that? A minute ago. Okay. If I put a body of water in the middle of a continent, how big would it need to be to start counteracting aridity to a decent degree? Well, if you... so there's two parts to that. One is the sort of broader configuration of the land masses that you have. For example, the Great Lakes do a decent amount to provide a lot of extra precipitation to the areas around it through lake effect snow, we can see a similar thing, especially on the southern coast of the Caspian, where you have a rainforest, like a very lush ecosystem down there. But to get significant amounts of precipitation, it can't just be an endorheic basin or a large lake. It really needs to be like an ocean basin. And you can look on the smaller side to, we've talked about like the Arabian Sea or the Bay of Bengal. So that kind of bay protruding in can provide a decent amount of precipitation. Like, we talked about the, what was it last week? Like Port Angeles and Victoria, and how there's a lot of precipitation coming off the Salish Sea, particularly the Juan de Fuca Strait and the Georgia Strait. A majority of Port Angeles is, was it 750 millimeters of precipitation, about 600 or more, come from cold winds passing over a very small amount of the Georgia Strait. It's like 100, 150 kilometers, and there's a bunch of islands in there too. So, especially near the coasts, it doesn't take all that much water, ocean water, assuming that they're not under a high pressure zone or high pressure area in order for that to happen. But if you wanted to get into the interior, we can just take a little. Can we hear birds? I think we can hear birds. That's nice. Let's look here. So if there wasn't the Tyche Basin, do I have a layer on top? Okay, let's add another one. And let's change from the CSC color, because that is going to become confusing at some point. If we did not have this, and this is, rather large, again, that whole area is, like the size of like the European subcontinent, including like North Africa and stuff like that, like as big as the Mediterranean world itself. But we can think of the Mediterranean. The Mediterranean provides a lot of, on Earth, the Mediterranean provides a lot of precipitation to the areas around it. And precipitation from moisture from the precipitation, moisture from the Mediterranean becomes precipitation as far away as Central Asia. So in Afghanistan and Tajikistan, the precipitation that happens in the winter comes from the Atlantic and the Mediterranean. So it travels a really far distance over, the steppe of Central Asia before hitting the northern and western side of those mountains. I believe like the Karakorums and stuff, before precipitating. So, you could, if you wanted to go for like a minimalist side, maybe like you could have like the western basin of the Mediterranean or something like that poking in, and that would provide precipitation, a decent amount of precipitation to the areas around it. There are a handful of islands, say in the around Dalmatia, across the Adriatic, and the Adriatic is a very small channel, but there are islands that on the sort of east coast, on the eastern side of, so for the Adriatic, like, okay, let's just do this real quick. So you've got the boot, right? So this is Italy. We're going to imagine this is Italy, and then you've got the coast here, and then there are little islands in here. And when precipitation comes in the winter, and it's going this way, it precipitates. You have very rainy mountains in the center of Italy, and then these mountains, these islands along here, are getting precipitation from the Adriatic between them, and the Adriatic is again like I think maybe 100 or so kilometers, 130, something like that, wide. And these little islands get about 600 millimeters of precipitation in the winter, which is more than enough to make them Mediterranean. Um, but yeah, if you wanted to, you could do like the size of the Western Mediterranean, and that would do a decent job, especially for the places around it. You probably get some precipitation going much further afield. Um, the Mediterranean itself is sort of a good example of like a bit of a middle ground for the size of a basin that you'd want in there. And if we go back to the one we're working with now, we can see that the Mediterranean is about the same size as I don't know, this northern basin. So something about a third of the size of the Tyche could do a really good job. 10 out of 10 Italy drawing. Thank you so much. I mean, yeah. I mean, I did have it right here. I could have come back. See, here's the Adriatic. We got the Adriatic. Got a lot of little islands along there. And when the winds are coming this way, they hit the mountains, and then they come down. They collect They collect moisture, and then precipitate over here. So, and there is like a marked difference in the climates along the Adriatic coast here, where the precipitation is coming there. So they, but then there's also precipitation coming from this way and from that way. So, the Black Sea is also an interesting one. But something, that sized could do a decent job. But it is, but it is really about the surface area, right? So if you want, and something that I was talking about with, I think this is something that Edgar talked about when I talked to him about redoing the precipitation map, because he did a precipitation map with winds and stuff like that, and he wasn't really happy with how arid it was. And Kritak, Trofeld is super arid, no question. It is very big. A lot of the landmass is really far away from the ocean at the coast. But you want to think about the fetch. So the fetch is the distance that the wind is traveling over the surface of a body of water. So, and a rule of thumb is the precipitation, and if you're using like the dry, wet, very wet model or whatever, the precipitation is only going to, significant amounts of precipitation is only going to travel at surface level as far from the coast as the fetch is long or wide. So here the fetch is, again, let's just say 130 kilometers. It would only travel 130 kilometers in. Like that's how much precipitation, that's how much reasonable precipitation you would receive. However, this changes when the elevation increases, because the elevation is going to squeeze more moisture out of it, which is why you can have, moisture passing all the way over here into Central Asia and then precipitating on mountains in Afghanistan, Tajikistan, stuff like that. So yeah, you want to keep the fetch in mind. So if you want your precipitation, using the map of Europe here, to go here, how much of a fetch would you need, right? So you've got here and then here. So let's just say that's right. And well, that's not, that could work, right? If we're just using this rule of thumb. But if the wind is traveling over here, and then, yeah, you could probably get some precipitation out there if you're doing that. Geographers making fetch happen. Yes. That's such a fun movie. Gretchens of the academic world. Um, so yeah, so the concept to keep in mind is thinking about fetch and how fetch your basin is can really determine how far the precipitation goes at surface level. And so, and that and it does require that you have, you know, the surface winds that are picking up the moisture. So again, if you have a high pressure zone, you're not going to be seeing that. So it really is, you know, the surface winds moving over it. And of course, you know, if we use the oceans, like they have, you know, oceans have massive fetch. So one of the things that I wanted to make sure could happen, and we can look at the world map again with Happy Sun. And so we have winds, you know, moving across here, especially in the summer. I mean, I can just bring up the summer maps. I don't know. There we go. So, you know, like the interior of Linnea, for example, right? Like we have, yep, there we go. Let's change the color just to make it a bit more visible here. So you know, you have the wind moving across here and then moving into the interior of Linnea. I mean, we do have some mountains along here that are going to catch a lot of that precipitation, which is why we have the desert in the central part. But the large fetch. Oh yeah. Oh, it's under that. That's interesting. But this large fetch, you know, allows the precipitation to get in. So that's the rationale behind it, right? And because this is the equator, so, you know, I wanted to make sure that we were getting a decent amount of precipitation in here. And to do that, you need to have enough of a distance, you know, you need enough surface area for the wind to move over to pick up enough moisture to get it in there reasonably. Oh yeah, I can do this. I always forget this. All right. You know, rain shadows, but how does some precipitation go over these high peaks to precipitate elsewhere? So you see a rain shadow effect usually after, what is it, like 2,000 meters, you start seeing some form of rain shadow effect. And I think yeah, like the Cascades. So you do have situations where, and I think I illustrated this before. Here we go. Yes, this illustration. Look at me. So you have Mr. Sun, you know, Mr. Sun up here. Mr. Sun is heating the ocean, and the ocean is then evaporating into clouds. The clouds move against the first mountains, and they are going to precipitate. And there's also going to be evaporation. So there's going to be evaporation from the precipitation that's happening here. And as the cloud goes up, it cools. Cooler air masses carry less moisture than warmer air masses. The moisture condenses and then precipitates. However, there is less moisture in the air here than there was here because a lot of it was precipitating out. And we have to remember there's not going to be as much evaporation happening at these higher elevations because it's cooler. So there's going to be less moisture on this side than there is on this side because, you know, the moisture condensed and precipitated here, and not as much evaporated back because it's cool. Well, it's cooler relative to the ground. It's going to be colder. So on this side, you have a air mass with less moisture, and it is not, and it's also going to be warmer because, you know, this area here is going to be at a lower elevation and warmer relative to the mountains, and warmer air masses carry more moisture. So it's not going to precipitate as much until it's forced over the next range. And when it's forced over the next range, it is going to precipitate. So this is how we can have like the Rocky Mountains, right? Or the Western Cordillera, where you have multiple ranges, one after the other. And, you know, if you look at like I don't know, if you look at a Köppen map of Canada, you see that like a decent amount of it is going to be, what is it, like DFB or something like that. You do start to see BSK in like the Okanagan, around Soyuz. There's a desert there, and you're going to see like patches of BSK between the different ranges, and that becomes a lot more pronounced as you go south into the United States, because it's warmer, right? And we've talked about how you know, the relationship between temperature and precipitation creates deserts. So some precipitation does end up going over the peaks and going elsewhere, though you usually need higher peaks in order for that precipitation to come out. Right? So, or, you know, significant peaks. And in the case of something like the Mediterranean, where you have, you know, well, it's red water, it's orange water, it's fine. You have this, you've got some mountains, and then it goes down, and then you've got huge mountains up at the Himalayas, you know, comes up, turns into clouds, precipitates. We're gonna call that precipitation. And then the cloud just travels. And it's going to precipitate a little. That looks more like evaporation. No, it doesn't. That looks like precipitation. Great. So it's going to precipitate a little as it moves across, which helps create the Eurasian steppe. But once it hits the Himalayas, it is going to rise, it is going to cool, and whatever moisture is left over is going to be forced out. Oh, hey, Huelos. Great to see you. Have you been? Do you have a cat on your keyboard? So I hope that's helpful, writer too. This is live climate support. All right, let's get back here. Oh, okay. There we go. That's nice. Right, now we are doing ET climates. Wonderful. Oh, that's awesome. Oh, well, I may mute you if you're going to be commenting, you know, just kind of type salad. So. All right, so for the ET, we are, I want to go back to picking a different color because I don't want to use the same colors for this. All right, so up here, so what is 2 kilometers? So by 2 kilometers, we would certainly get an ET climate because the 19 would be going down by 12, but I want to know exactly kind of when that happens. So where is my little thingy? Here it is. Boom. Great. What? Okay. Too many unlabeled layers. All right, so 1.5. Oh, because it starts at 22. Great. So yes, 22. It would be 2 kilometers. Okay, perfect. And that is down here. But what would it be for there? Okay. Stream looks good. Yes. Have a good night. Oh, well, that is not what I did. It said timeout. Ugh, whatever. I'll have to go back and check that. When it communicates timeout to me, that is not what that means. I'll send them a comment later. All right, so, but you can't be coming into folks' streams and posting word salad. That's not very polite. Okay, so, yeah, so it's along the 21 line, which is fine. So that would be 21 and, yeah, I think 16 is fair there. So 21 and 16. At 1 kilometer is going to be 15. I shouldn't click. I should be making those noises. All right. 15 and 10. Right. And then 1.5, as discussed before, would be another 3 off that. Right. So that would be our 12 and 7. And then what would it take? Yeah, I think it would be the 1.75 mark. Okay. And I only want to sprinkle this in the middle because it's going to be the highest peaks, kind of, that are going to be having this tundra. And meanwhile, yeah, I'm not going to have much down in this area, so I think I'll probably stop it around here. Yeah, that's fair. All right. I was a little overzealous. But I think this is the, primary spot where we're going to have it. And even though the mountains are not as tall here, because the temperature is decreasing, we are still going to get, relatively more. ET. I think it's kind of homogeneous, but that's okay. All right, now we are going to go up here and see where the ET emerges. All right, so what's going to take, I think it's about 1,250 because it's already there at 1,000. Yeah, okay. Yeah, just go straight to ET. I think we had a question about that last time. Do we have any D climates on these terranes? And no, we do not. And so last time I suggested that we were going to go in sort of a counterclockwise direction. I think that's still a pretty good idea. Though I wouldn't be opposed to going up from the deserts, but I don't think that's equally as exciting. And we haven't done, yeah, I mean, this allows us to do those deep climates sooner. That people are clamoring for. Clamoring. Yeah, because up there, that just kind of happens really quickly. So we're going to have a lot of tundra. Though I don't think by 2 kilometers we're going to have any EF climates. There we go. Well, that looks nice. All right, and then the final, I believe. Yeah, so we do have... I did cut it off rather abruptly there. But that's okay. So we do have 500 meters there, but I don't think we're going to see any CSB in that area. Yeah, like the Cascades. I already showed that one, didn't I? Yes, I did. Yeah, 500. All right, so let us bring back the all-important calculation layer. What is it like right here? And this is in the winter, so it's going to be cooler on that side, so probably closer to the 14. Yeah. 14 instead of like a 15. Because, this side is going to be a little warmer. So we have 14 and... So this one... What was the normal circulation? Yeah, we got warmer water coming up. Yeah, I'd be willing to say that's 20. In which case, it is exactly like that one, and we will see nothing. So it'll just be a C. Cool. I think the main difference we may see here, depending on how much elevation is, we may get some CS or CB extending into the AW region. Yeah, because we do have some elevation there. It goes up to 500 to 1,000. So if anything changes at 500, that's what we'd be interested in looking at. So it is within the 22. So yeah, let's just say, let's look at the middle. Yeah, we just go to the 22. Because if we know at the 22, then, we can count out everything above it. All right, so 22 and... Okay, that is about 17, let's say. So 22 and 17. We would see CSB then. Oops. Yeah, so we would see CSB rather quickly. So I'll probably add that in at the 250 mark. We'll probably get a similar look to the main terrain. So like looking in here, let's get rid of that for a sec. So the CSB kind of here. Yeah. Easy. All right, and we do need to check down here. This is the one that I'm interested in. So, because I want to know if it becomes CSA before switching to CSB, because that is something that we can't have in a transition from an A to a C climate. Usually, the more oceanic, especially hyperoceanic regions, it tends to just go from A to CB rather than going through a CA spot. Right. So, okay. So that's the 18 and the 18 and well, so within the 22, but not significantly. Well, we'll do 22 and a half. See what happens. All right. So yeah, or 23, I guess. What did we do? 22 and a half over there? Yeah, 23 at that peak there. So yeah, we can have 23 down here, I guess. But the thing is, any drop. So the moment this shifts below 18, we would get a very thin CSA. We would. And then down here, down here, 18, yeah, it's 19, whatever. So a 1 degree drop would still be a 2 degree drop. So because this is 19 and 23, a 2 degree drop would give us 21 and 17. Yeah, it would be 22 and 18. If you drop this, you can't have a CA anymore. And if you drop that, you can't have an A anymore. So it has to be a CB. Okay, so I can have some CA coming out. I'll have some CA kind of coming out along here. I believe there's yeah, so that'll probably be where that ends. So let's just... And then I will certainly have a CB region in here. Yeah, and that'll be about it. I don't like the shape very much, but that gives us the general idea. So we have that highland region. What was the difference here? Oh, 19. Yeah, 2319, 2318. Oh, I think I made it 24 instead or something, didn't I? No. So in this case, too, the CSA shouldn't really be there. Because there would have to be, for it to be there, you need 23 and 20. She had 23 and 20. I mean, the CSA can extend out a little bit like it does here, but at some point it would just be... Yeah, it'd have to be 23 and 17, or 22 and 17. Which happens here, but not there. I don't know, I can make it 23.5. But if I do that and make it 23.5, then I have to do it for this one too and also give it some CSA. So you know what? Let's do that. That adds some visual interest, I think. Why not? I might hedge back the CSB then on this side if I'm doing that. There we go. Hi, old growth forest. When did you show up? 2 minutes ago while I was looking at my screen. Yeah, I'd probably want to get rid of more of it. Because this is the mountains here are not as the highlands, I guess. The hills here aren't as significant. Boom. Yeah, I don't like that. I prefer it to be... I preferred it when it was just CSB. And it makes more sense. What was the rationale for this? Mm-hmm. Oh, yeah, well, that's the same rationale for there. It may be closer to some of the warmer waters coming off, but I think what we may see is I think what we're likely to see is this transition here ending at some point. Because if it's fine at this 22.5 spot, it wouldn't work going to 23. So, yeah, I'll probably just shave it away and probably replace. Yeah, let's do that. Let's shave it away. And I need to be on the level here. Okay. Yeah, 2318, because then it would become, oh, excuse me. If it's 23 and 18, no, it was 24. I changed it to 24. Okay, so if it's 23 and 18, then it would become 22 and 17. And 22 and 17 would be CSA. Why am I thinking this? Let me see the July temperatures again. No, 24 is all the way down here. No way is it 24. Can't be 24. I think 22, 23 is quite generous. I don't know what I was thinking. So yeah, this is silly. Yeah, the 22, just above 22, which 20.5 can just be a stand-in for, is reasonable. And then if I bring in the January temperature, you know, yeah, 18.5 is also reasonable. 18.5, which would mean that it would immediately go to CSB. That's fine. I can have the CSA creeping in a little bit, but it should definitely immediately go to CSB. So what I will do for that, and we'll go to CSB rather quickly. So this can get cut there, and that can go into, that can go up like that. And then I can just go along there. I can nab that. I want all of it. Oh, that's great. And then go to CSB and just cover it. There. Okay, and then go to CSA. Cool. Well, it wouldn't really look like that. You know what? There could be a hill there. Nah, no. Shouldn't look like that. Yeah, I'll have to get the shape right a bit later. In Norway, there's temperate rainforests in the Arctic Circle. Oh, that's cool. Yeah, I wouldn't be surprised. You can get a decent amount of precipitation there and probably have a good amount. Though, I don't know, sometimes people call things rainforests that aren't precisely rainforests, but I would have to see. I do believe you, though. I think that's interesting. Remind me of southern Mexico for some reason. I think southern Mexico is quite close. There is a spot on the, especially the western coast of southern Mexico, where you see an AW region transition into a CS region, and that is definitely inspiration here. Yeah, yeah, that's definitely part of the inspiration. Yeah, I think that it's a little sharp in the curve, but that is more or less what it should be, and it is on a similar line to here. Though I should probably go back in with the CB and there we go. Cool. There. That's more or less the terranes as we've worked them out. And what time is it? Oh, we're an hour in. Wonderful. So now we will go and look over here. But first, we are going to take some time and worship the sun. Please, everyone have a stretch. Stretch for the sun. I'll be back in one moment. And we are back to Lands Unknown very quickly. All right, let's see. Oh, my hat got messed up putting on that. There we go. So very quickly, I just wanted to take that down. 'Cause with these conifer forests, I just want to make sure that there's nothing in my, whatchamacallits. Come on. I'm not very good at navigating the iPad. Aha. Because I have been working a lot on the biogeography and the speculative evolution stuff, I have a lot of tabs open to things that would give away the surprise. So here we go, Norwegian conifer forests. Let's look at those. Coastal conifer forests? Let's go. Okay, let's bring that back up. Scandinavian coastal conifer forests. You're right, Scandinavian coastal conifer forest. There we go. Welcome back. Thank you so much. So I noticed that, because I did watch back the last stream, and I also did a private test stream where I just recorded myself sitting here for 2 hours talking to myself about marking. And I did notice that the audio and occasionally the video skipped, especially when I was streaming the video. And that is because the router is in the other room. So thanks to the Patreon supporters, I was able to pick up 75 feet of Cab 6 Ethernet cable and some cable pins or cable clips with some nails on them. And I'm going to run that along up the wall and across the ceiling into this room, and then and then into the laptop. So we will have much better quality for the stream and the audio. You know, we won't have the clipping and the pixelation and that sort of stuff, because when I record, I can see myself and I look, you know, the video looks fine. So yeah, so that should be done by next week, for next week's stream, which will be pretty cool. Yeah, Cat 6 will certainly do it. Yeah, Cat 6 will certainly do it. So yeah, and thanks to the Patreon supporters, that was a possibility. Yeah, you can go sign up for the Patreon if you haven't already. You can become a free member for the Patreon, and you'll get updates for when the live streams are happening. The next video should be available to explorers on February 2nd, and then it'll be public on February 6th. So if you'd like to see it early, then there is a tier available for that. But even if you get in the lowest tier, you can see the monthly updates. And I think everyone who, yeah, and the December and January updates both introduced creatures that are going to be in the first, in the next video that nobody's seen yet. So that'll be super cool. Yeah, awesome. And the updates also include some stuff that's going on for me, as well as the timeline for the videos. And just some of the other stuff I'm thinking about. So if Patreon Patreon members haven't gone and checked those out yet, then totally recommend it, because you can see some of the fauna that have not, that you'll be seeing in 2 weeks, week and a half, something like that. All right, let's look at these Scandinavian coastal conifer forests. Gorgeous. Okay. Small areas with botanical features and local climate consistent with temperate rainforests. Okay, yes. So I was skeptical that you had large regions of temperate rainforest, but I could see small regions, especially at some of the higher elevations, because there's certain things you look for when you're looking for a rainforest. One, temperate rainforest, one of them is a lot of like lichen and moss. You're looking for a canopy, where you have like lots of trees, but you're also looking for a really developed understory as well. So You know, you've got trees. You're looking for a lot of like, you know, shorter trees or a lot of shrubs. And then you have, you know, your more herbaceous ground cover and shorter shrubs and stuff like that. So you are really looking for like multiple tiers. So that's what you're looking for in a rainforest. So you can support a lot of flora. What do we got here? Ooh, seabirds. Ventempa Klima, cool. Where do we get some of the... We know... Okay, boreal rainforest, that's what we're looking for. Huh, that's interesting. That looks... That's not really what we're looking for. Looks promising, it looks really lush, but that does not look like a rainforest. Yep, high humidity, shield from the sun. Most locations off near waterfalls. Rich understory of mosses and ferns. Okay, okay. Is that what we're seeing here? See, this doesn't look like what they're describing. I'll have to look at some other pictures. But what they're describing here, this rich understory, is really what we're looking for. Diversity of... Yeah, here we go. Diversity of lichen or lichen. That's really like the big thing there. Oh no. Don't burn your lunch. And we must respect the sun and the energy it brings, not burn things with it. There's some boreal rainforest with closed canopies in Alaska and southern Siberia. Yeah, I know about the ones in Siberia and Alaska. I wasn't aware of these, which look interesting. Oops. That's me smacking the desk. But yes, this description of having a lot of lichens, as I mentioned, is something that we're really looking for, or lichen, whatever we want to say. Oh, it's just a district. Okay, maybe there's some other pictures that we can find by going back. Oops. Yeah, I need to figure out a new desk at some point. Yeah. That's what we're looking for. But like, see this, like this understory with all of the, you know, lichen, lichen, and, you know, this, you can see like a lot of the, you know, younger conifers are in the understory. You can see the ferns and the herbaceous growth. That's the kind of thing that we'd be looking for. Yeah, that's really cool. I wish there's some better photos of it. Oh, okay. There we go. Yeah, that's nice. What? That was... Where is that photo? Okay. Oh, we got some down here. Okay. That's nice. Yes, that looks very rainforesty. That looks very boreal rainforesty. Beautiful. And of course, you know, on the island, we do have, you know, a lot of like timber rainforests. So this is very familiar, even though it's on the other side of the Atlantic or Pacific. I mean, it's probably about equidistant at this point. What else we got here? You're heating some chicken. The bag instructions said 5 to 7 minutes in the microwave. So I said to 5. Then my mom was like, "Are you sure that's for the whole chicken?" Oh no. Oh, I see. You were reheating some of the chicken where the instructions were for the whole chicken. Ah, okay. It can still grow for us. That's really cool. But do you know what is gorgeous? Sand dunes. Oh, and this? What is this? Sea rocket and sand dunes. Can you eat sea rocket? This is a very important question. See, whenever you see a plant, the first question should be, can you eat it? Let's look at this one. Doesn't tell you if you can eat it. See, is it invasive? It's interesting. They're rather similar to wild radish, but you need careful attention to tell the two plants apart. Is that because this one's poisonous? They're edible, preferably cooked and not eaten in great quantity. Aw, not great quantity. That means it's a delicacy. I wonder, ooh, European sea rocket. Ah, I see. Yeah, so you can eat it, but you probably don't eat too much of it. We will consider it a spice. Oh, and it's around here too. I've probably seen this. Oh, no way. That doesn't look like that other one we were looking at. The other one had pinkish leaves. Oh. Doesn't that one have like pinky leaves that have more lavender leaves? No. Okay. I may try to find some of this around me. Yeah, the sand dunes with the, growths of vegetation with the little pink flowers. That's very pretty. Going in the mood board for Dove. I think this would be actually very nice on the northern coast of the Tyche Basin. So let's get back there. Come on. Whoop. All right. We are back. We don't need to see me anymore. There we go. Whoop. Thank you, Mr. Sun. All right. So now we are moving into the eastern coast of Lanea. And here, just to throw this on, we do have some uplands. We have some hills from some very old orogenies that occurred during the formation of Lanea. This happened before the creation of Uya. So, these hills are exceptionally old. Yeah, these hills are exceptionally old. They, are rather small. They're more of like an upland region, not particularly mountainous. But they do offer, some visual interest, and they do collect some of the precipitation so we can, because on the one hand, I wanted to mediate the aridity of the supercontinent, but on the other hand, I did want to have that really big desert in the middle of Lanea. So, I had to pick my battles. And what do we have here? So, here we have, this is a CF down there, which I maybe moved to. I think originally I put it as a CS on this map. And then we've got CF in the bottom, and it transitions into DF. Inside, it becomes DW, which is likely due to, in the winter, most of the precipitation, I should be demonstrating here. Boop. Okay. Most of the precipitation is going to be moving that way. I mean, we will have some like coastal interactions here. I believe the winds are moving that way off of Lanea from the interior. And what have we learned? When we have these cold continental air masses that are dry, like coming off an interior, they can create like snow squalls and all sorts of things. They can also drive, orthographic lift. Was it? No. Lee cyclogenesis is what the term I'm thinking for. It also it also has like the Lee cyclogenesis, and that's gonna like pull in precipitation as well. So even though, and you don't need that much precipitation in order for a place that could be a DW climate to become a DF climate. Because if we think of Köppen, you need, in order for it to be a DW climate, the wettest summer month needs to have 10 times the amount of precipitation as the driest winter month. So, if the wettest month receives, 100 millimeters, if the driest winter month gets 12 millimeters, it's suddenly a DF instead of a DW, right? So it doesn't need to be a significant amount of precipitation in order to change, depending on what the wettest winter month is. So if your wettest winter month is something like, 200, then that can make things very different. But in this case, the amount of precipitation that's being received is not going to be that high. So let's turn off some of these layers here. Bonk. Great. So this is the summer. And during the summer, we've got low pressure along the coast, and that is going to be pulling in precipitation along here. You're going to have storms and things as well because it's in this low pressure band. Right. However, we also need to look at June, wherever June is. Where'd June go? I swear I had June. All right, I may need to import June again, and in that case, we can switch to me so that you don't see anything you're not supposed to. I don't want to ruin the surprise, because the surprise for the animal video is going to be pretty cool. Okay, there we go. So I want to just lower that. I swear I had it. Did I delete it at some point? That was a very strange choice on my end. I may have done it by accident. Something I've really noticed since starting to listen to podcasts, especially for Americans, is a lot of Americans don't say they did something by accident. They said they did something on accident. So I think that's like, yeah. Oh, I'm getting some of that. Waiting anticipation for the animal video. Yes, the biogeography video will be very fun. And there's a whole group of animals that haven't been introduced yet because we've seen the monotrematiforms. Everyone will have seen the capals, which are the horsey-like ones wearing jumpers, sweaters. And then I did the Yale, which is, kind of like a tapir-like bovid, I suppose, in the, kind of the chimeric body plan that it sort of has. But we haven't seen a whole different group of animals that is going to be important and interesting. And of course, the monotrematiforms are a diverse group of organisms in their own right. So this is more or less correct. This is how I line everything up, by the way. It is just the easiest thing to do. All right. So in the winter, we've got an area of kind of like middle pressure in here. So we're not expecting too much precipitation. And really, this high pressure area here is what is, and that kind of spreads out from the Palomian ice sheet, is the limiting factor for the DW climates here, right? That is really the limiting factor. And what we have is, as these cold winds are coming off the continent, we are going to have some of that Lee cyclogenesis in the hills. And that's just going to drag up precipitation from the Tyche. However, it's not going to be too much precipitation. The other thing we need to consider is that, while we do have winds going this way, we can also occasionally see winds coming this way from the Agathie, and that is going to be carrying some precipitation with it as well. It's not going to be terribly significant, but there will be winds moving that way. And while that won't do anything to alleviate the DW climates, it has another avenue for Lee cyclogenesis to kind of pull precipitation from the water. So when you're doing your winds and when you're thinking about your precipitation, you're not just thinking about which direction the wind is going and being like, oh, well, the wind's going that way, therefore that's where the precipitation is going to be. We do have some other, local effects that are going on. Oh, there it is. Shoot, I had it in a place I didn't expect it to be. Yeah, there we go. See, we can see those arrows moving in. Ugh, I should name these groups. Some of them just say new group. Okay. So now, moving into here, the first thing that I'm going to want to do is make a new layer, and I probably want to do the DF first, but in order to do that, I need to figure out where we're going to separate those two climates. And for that, I want January to be up. I want to go to our temperature layer that we have here. And so when we look here, we can see that this is 12 degrees C. Let's do the blue color for that. And I may want to hard code it into January, so I'm not constantly, that's 6 degrees C. This line between the white and the light blue is 0. And then that is going to be 6. And then we've got 12. So this line here is going to be the dividing line at surface level between the C and D climates. Yeah. And so this is why I made part of this island in here. Oh, can't see that, doesn't matter. Into a CF, I think, especially in the northern part, in my original one here. But I think I made too much of it CF. So I'll probably just work on the area that's closer to the low pressure. And we need to know whether it is CFB or CFA. And to do that, we are going to go to July. Oh, wow. Okay. That's really close to the 24. So this is going to be a CFA region. And I think I've got that color. Wonderful. Wonk. Very prepared with all of my colors here. Yeah, so let's put it on top of the CSA one. Rename CFA. Don't make it crazy, please. And we're going to throw all these on. Is that really what it's supposed to be? That doesn't seem right. I guess it is. That's supposed to be CSA. Is it CSA? It is. Okay, then. Let me just see. Okay, so yeah, and yeah, so that's going to be flowing that way, and that is going that way. So I will I think the main factor here is how close it is to that low pressure zone. There we go. Yeah, it looks nice. I do need to go in with black to make sure that I fill in the outline. There we go. And we're going to see more of this CFA extending to the 0 line in January. And remember that 0 line is going to be right there. So let's just do a line across here so we can remember. And then we can go in and clean up that base layer, which I have called outline. I see. I think there's a setting I can turn on so it doesn't paint with my finger. Because whenever I touch it with my finger, it seems to be doing another tap. I'll figure that out. Watching on mute, but glad to see it's still going. Sorry I had to chat last time. Hey, no problem, copyright infringement. It'll keep going. We will never stop. Never. All right, so we do see that the 0 line also comes out over the ocean a little bit, just away from the coast. So I am going to undo that black stroke that I made. I thought I I'm going to make this come up to about here, I suppose. There we go. All right, so that is going to be where the CFA is going to, is at the very least. The rest of it is going to be D. And I don't have the colors for D, so I will use a color and then figure it out later, which is all fine and fair. I can go to the other one because I do believe, oh, no, I can just grab it from the background. What am I talking about? There we go. Easy. So what we need to do is figure out the temperature now at ground level in July. So this 18 line at surface level extends all the way up here. And so I'm going to, above here, put in my DFA layer, not daft. Right. And I'm going to put in this here, and then I'm going to lower the opacity so I can see the intersection. So then I can just draw that line in. And we're doing surface level. I'll go in afterwards and figure out the sorry, brain fart. Yeah, I'll go in after to see where the DF, the DFW is going to be, and we're also going to, change the elevation as we've been doing. So now, since I went all the way up there, I'm going to turn that off and just focus on that 18 line. And like this line is very, yeah, that line is kind of sketchy. I would probably want it, oops, drop the pen. Probably want to kind of come out and go around these coasts just to have a little bit of DFA right along it. But we see like there's a very sharp distinction between where the oceanic and like subcontinental zones begin, especially at this high latitude. We see all that bunching start to happen. I mean, I'm not going to be doing the north, but since I'm doing the DFA, I might as well do it anyway. Let's bring that in. Okay. Go all the way around. How do we got here? So yeah, so these coasts along the north of the Tyche Basin, as I'm thinking, would be very cool for those sandy deserts with some of those, what was it, snow something or other? Snow rockets? That's pretty great, snow rockets. All right, so let us Oh, yeah, that would be a problem. Hmm. Let's do that along the coast. Usually I organize my layers just in the order that I do them, more or less, for each kind, just to make sure that there's no overlap. There's going to be, ooh, some of those little islands are going to be DFA. That's cute. Or would they be DFA? Where's the zero line on this northern coast? Oh, okay. Yeah. So we got the zero line up there too. Some of these cute little islands would be DFA. Any other cute little islands? Nope. See, sometimes I get to surprise myself. Because you can't always see the little islands, especially when it's like, you know. So then you're drawn along, and all of a sudden, got an extra pop in the middle of the Tyche. Hmm. Yeah, we'll say that one's DF, because I think that's going to be a little DF region there. And now we've done that, we can just start filling. I don't need to be too meticulous about it because there's going to be these elevation changes, which are going to, yeah, there are going to be those elevation changes, and those are going to be what we're concerned with for, you know, making like the DFB and DFC and stuff like that as well. There we go. So there's the DFA more or less. I can go in after the paint bucket to catch some of those strays. Out of curiosity, what were they last time? Really? Okay. Well, yeah, because they wouldn't be 22, would they? So this region probably won't survive being DFA. Right, because the 22 we discussed ends up there. Yep. Because it is pushed north during. Yep, because the warm water goes all the way up there. I don't know, I may. And then where does that end? Let's do... Yeah, let's do that. Yeah, that's nice. Would that mean these guys are over here? Where do they fall in this circulation? You know what? Maybe we can have a little thin strip of CSA along there. Yeah, I like that. Yeah, that's nice. So, from here, we've got this DFA stuff blocked in. We can now start thinking about the elevation changes and how that is going to impact the CF and DFA that we've created. And then after that, you know, we can go in and add the DFB elsewhere because there's going to be a lot of DFB. But as normal, in order to do that, we've got to set our climate stuff in our temperature layer. We can add a new temperature layer and we will name it temp Western Basin. And this is the temp for the Central Basin. Just so I'm not frantically trying to look for it. So down here it is right on the 24 line. And in the winter, that is around the 12 line. So 24 and 12. That's pretty good for the CFA. But it is going to drop. And we'll say, you know, it's going to be humid. So when you have humid air, it's not going to cool down as quickly as cooler air. Especially, you know, when we're thinking about the summer and the winter. Yeah, especially when thinking about the winter. But I'm thinking about the summer here. So for the 500, you know, if we take it down by, you know, 2 degrees, which maybe, you know, 300 we'll see, because we are using our guides to kind of figure out what the elevation is going to be. That would be 10, if we're thinking about that. It's going to be drier, though. Yeah, I mean, it's not... How about this? Let's just do it normally and see what happens. So 500 would be 21. So that is where we would see the drop to CFB. Still very warm CFB, no question. But we are not going to see this go to a D climate, at least not here. Yeah, and we're probably going to see the transition sooner than 500 because it is the drop from 22, which will occur between the 250 and the 500 elevation mark. What we have to keep in mind, though, is that this is changing quite sharply, because by here, you know, that 3-degree change. Yeah, so it's going to be, we need it to be about 1,000 here in order to get the transition to a D climate. And I don't think it actually gets that high. No. So 0 to 250. So we've got 250. Yeah, 0 to 250, 250, 500. And then this goes up to 1,000. So we do really just need to worry about the 500, but it seems like this whole peninsula is going to be the CFA at the very least until we get into here. It's going to be in those regions that we're going to see the transition to CFB. And depending on how close it gets to the 0 line, we'll have to transition it to DFB. So yeah, we are gonna see that transition. I don't think we're gonna see yeah. So it'll be the CFA at surface level is at 0, at sea level. Sorry, the CFA at sea level is going to transition to DFA, and then the CFB at elevation is going to transition to DFB. So let's grab our CFB here, and we can toss that in and include that around 500. But as I mentioned, it's probably going to happen prior to that 500 transition, so we can make it a little larger. But I also don't want it to get out of the CFA zone. Oh yeah, already well out of the CFA zone. Okay, cool. And then I'll just throw the DFB on top of this, so I don't have to worry about it. Okay. Yeah, there we go. It's more or less where we're at. So then for the DFA, we can throw in the DFB layer. Wanted to correct it to DFA. That's not. And we can go to the climate one. There. Yeah, so when I was doing this, I made the elevation transitions too sharp on the lower resolution global map. And, I did that because I was just sort of selecting each elevation layer. And when I was selecting those elevation layers, I was then, just like, well, everything with this 500 is going to be, in this case, DFA or DFB or what have you. I wasn't working on this like more granular scale, in which case we do see like an interesting spread of sea climates a little further north on this peninsula, which is nice. So for the D here, we are going to, the DB here, we're going to go into there. And then we can switch. And we're also interested in here. But to see when that transition happens, now that I've kind of blocked some stuff in, we can turn this off and do some climate check, do some temperature checks. And for the transition, the threshold between C and D can be 0 degrees Celsius. That's the one that I use. You can also use the -3 degrees Celsius isotherm. I think using the 0 degrees Celsius isotherm is a lot easier, especially when you're doing it in these 6 jumps. Because if you wanted to do an isotherm every 3 degrees, that would just be more work. That is one thing. But since the 18-degree isotherm is the major difference between that differentiates the A from the C, then the 0 being the one that differentiates C and D is really useful. But you can also do -3. That is also an option. That's the one that is in the textbook for our geography, our intro to physical geography textbooks is the -3 degrees Celsius. Why are there two different definitions for the distinction anyway? Well, it has to do with the variation in vegetation and the different kind of physiologies that plants have. So when you have climates below 0 degrees Celsius, you start to see, frost and more regular snow. However, with the -3 degrees Celsius, you see different kind of adaptations in the vegetation and responses to the harder ground and a longer frost. If it's just 0 degrees Celsius, yes, you may have frost, but the ground may not freeze necessarily. So, the plants will develop differently. But yeah, thanks for the question, Alta. We also see some other differences in Köppen. So, for example, there's a difference in how B climates are categorized. So, one way to distinguish H and K arid climates is to use the average annual temperature. So if the average annual temperature is above 18, then it's an H climate. But if it's less than 18, then it's a K climate. And that's the one that I normally use. Another one is if the arid climate has a temperature below 0, a monthly average temperature below 0, so then it becomes a K climate. And I believe that's the one that Nikolai uses for the Apple Pie from Scratch guide. So, and oftentimes those two Ks will align and sometimes they don't. So, it just depends on what you're trying to capture in the distinction between BH and BK climates. If you use that 0 degree or -3 degree isotherm to separate K and H arid climates, then what you're getting is a similar distinction in flora to the distinction between C and D climates, which can be very useful. But with the But something that we also see is that uh, deserts that are in higher latitudes that have that, that do have monthly temperatures that go below 0 or -3 tend to be similar to uh, arid climates that, are in lower latitudes. Um, like, I don't know, what is it? There's the arid climates in North America that are in, what is it, like the Southwest? They tend to share similarities. And if you did that, then there would be suddenly a bunch of arid climates in North America, which would be labeled as, what is it, like BSH instead of BSK. But, it depends on what you're trying to highlight and what you're trying to differentiate. But it also means that when you are looking at climate, especially Köppen climate maps, you need to understand the logic behind it and what framework they were using in order for you to learn from it. Because if you look at one Köppen map and it uses one definition of arid climates, or it uses, one threshold for the difference between C and D climates, and you look at another climate map, from a different region made by different people, and it uses a different framework, then you're not going to be you're not going to have a consistent like base to sort of learn from and develop your own vibes. How's the progress? Oh, it's going pretty well. Let's zoom out and look at the progress. It is also about that time, though I do want to finish a climate check. There we go. And I'll show the transition for the next live between what we did this time and what we did last time. I do want to do a climate check for the bees, but so far, let's go to black. Wait, we don't have any bright oranges. Well, Köppen doesn't have like bright pink, so we'll just do that. So what do we do today? We filled in the higher elevations here, and we filled in higher elevations in there. We took some time to explore the Scandinavian conifer forest and check out some pockets of boreal rainforest that it has. We've also looked at the distinction between the F and S region of the basin. Kind of put a firm limit on the warm current here that spreads the 22-degree isotherm all the way up here, and added a little bit there of the CSA. We also did some refining around here because the AS would transition directly to CSB, and I had some AS going all around there. For some reason, I made it 23 degrees Celsius, even though it was pretty far away from the 24-degree isotherm. And I didn't want to move that. There are some things that are pretty hard and fast here. We also, did the elevation along here, and we checked in here and here, but there isn't much elevation difference in there, so didn't add anything. Spent a decent amount of time doing the ET tundras along there, and those tundras will be quite wet. So, while you may be getting 600 millimeters down here, up here, you'll be getting over 1,000 millimeters. So people will certainly be up there doing things, which is interesting, right? Like we're going to have people at different elevations doing things. I think this may encourage people to have a lot of vertical transhumance. So in the winter, They may be in, they may go to lower altitudes. Meanwhile, in the summer, they may go up to higher altitudes because it's cooler and more pleasant, especially down here, right? In these regions, in the summer, it's going to be hot and dry down here. Why be there? Why not be up here? Or there may be people who live around here throughout the year, but they're going to have much lower populations than the Dovians who live up in here. There could also be a variety of different adaptations. I'm interested in looking at those differences as well. But, we're going to be largely focused on Arukia, of course. So, after I kind of flesh out what the Dovians are doing there, which starts in chapter 3. So once we do all the biogeography stuff, What time is it? 12:12. Going for over 2 hours. Yeah, progress is going pretty good. Also had an impromptu discussion about, we're talking about rain shadows. We were talking about how successive mountain ranges can kind of squeeze precipitation out. Yeah, had a good time. Looked at snow rockets, which are a kind of herbaceous plant that seems to grow along coasts, and you can eat it. You can eat the leaves after they've been processed, but you shouldn't eat too much of it because there's, something in there that's not particularly good for muscles. I think it's carcinogenic or pathogenic, something like that. Mountains are neat. I agree. Right or two. Mountains are pretty great. So now that we are here, I do want to do a temperature check, and then, or we can leave that for next time because we have been going for 2 hours. Yeah, you know what? This seems a pretty good place to leave off. So let's bring me back into the mix. All right. So thank you everyone for joining me for this, weekly live stream. Originally, I, was planning on doing these a bit more infrequently, but they're actually a lot of fun. So I've decided to do it every month, and it also, keeps something interesting happening on the channel. It doesn't take much preparation or anything for me, so it doesn't really take away from the time that I have to work on the videos. Will we see deltas and sediment built up on the coast? I know it's a bit specific, but the basin is a bit wet as well as inland seas. Yeah, so we're going to see a variety of deltas. What'll be really interesting about the Tyche, in order for large deltas to form, like the Nile, for example, or we have the Mississippi Delta, you need like some very specific features to kind of come together. You need calmer waters, you need the currents to line up really well. So once I kind of go through and establish kind of where rivers are and take another look at the climates, and the tides is another big one to consider, then yeah, I can talk a bit about basins once we've kind of finished up doing the climate. And I think I'll probably talk about that while I'm doing the satellite map, which is something I did for Rukia. So we can totally spend some time to talk about that. I think having a guide or something for doing deltas is kind of beyond the pale because of all of the because of all the complexity that goes into it. We don't really want to model all of the things that go into it. And, if you wanted to model things like tides and stuff, then you'd have to be using like GIS software. You'd have to be, that can be quite difficult. And I don't think there's GIS software for measuring and generating tides for land masses that currently don't exist. I mean, I could look and see if there are paleo hydrologists and stuff like that who are doing things. Um, but yeah, I just have to look and see. But we will definitely talk about deltas. I think that would be quite fun. Thank you for the stream. Well, thank you for joining, Okurich, and thank you for joining, Catherine Ayer. Yeah, and thanks to everyone else as well. Like, like Rider 2 and was it Old Growth Forest was here, and of course Explorer Kate was here as well. So thank you everyone for watching and joining me in this stream. And join me next week while we will continue to fill out the eastern coast of Linnea, western portion of the basin, and then continue along the north. And when would the next one be? The next one would be February 1st. Yeah, and then the stream after that would be February 8th. By that point, the biogeography video will come out. So we can also talk about all of the different Dovian critters. So that'll be really fun. So see everyone next week. I pressed leave studio instead of end stream.